The next topic is movement and position. In this topic we will cover distance time graphs and speed. Then we will cover velocity time graphs and acceleration. This video covers specification point 1.2, plot and interpret distance time graphs. A distance time graph is one in which distance is plotted on the y-axis and time is plotted on the x-axis. See the skills section for more about how to plot graphs, but always remember to include the units. You will be expected to do two things with a distance time graph. The first thing you need to be able to do is interpret the graph. The best way to do this is to look at the gradient, because the gradient equals the speed. So, if the gradient is constant, the speed is constant. The smaller the gradient, the slower the speed. If the gradient is 0, the object is stationary. A negative gradient means the object is travelling backwards. You can also describe a journey by reading values off the graph. To find how far an object has travelled in a certain amount of time, you begin with the time, go up and across to find the distance. In this example, the car has travelled 10 metres in 1 second. To find how long it has taken a car to travel a certain distance, you begin with the distance, go across and down to find the time. Exam technique. When asked to describe the motion of an object in the exam, it is best to split the graph into sections. Then describe what each section tells us about the motion, and also, where possible, include values from the graph to support your answer. In this example, we would say, between 0 and 1.5 seconds, the car's speed is decreasing because the gradient is decreasing. Between 1.5 seconds and 4 seconds, the car is stationary, having travelled 25 metres. Between 4 seconds and 6 seconds, the car travels backwards at a constant speed because the gradient is negative. And between 6 and 6.5 seconds, the car travels backwards at an even larger constant speed. The second thing you will need to be able to do with a distance time graph is calculate the speed. Now we already know that speed is the gradient of the graph. So to calculate speed, we need to calculate the gradient. To find the gradient, we do the change in y divided by the change in x. In this example, the change in y is 20 metres and the change in x is 5 seconds. The gradient therefore equals 20 metres divided by 5 seconds, giving us a speed of 4 metres per second. Notice how the units of speed come from the units for distance, in this case metres, and the units for time, in this case seconds. If the graph had axes with kilometres for distance and minutes for time, then the gradient and the speed would therefore have the units of kilometres per minute. In the exam question, you may have to convert the units. Average speed is calculated by doing the total distance travelled divided by the total time taken. In this case, the total distance is 40 metres and the total time is 6 seconds. Therefore, the calculation is 40 metres divided by 6 seconds, giving us 6.67 metres per second. In this exam, 2 decimal places is always sufficient. Okay, so let's recap. To do this, let's just examine what the specification point asks us to do. It states plot and interpret distance time graphs. To be able to plot a distance time graph, you need to remember that time goes on the x-axis and distance goes on the y-axis. You must also always remember to include the units and label the axes. Interpret means describing the motion of an object, making reference to the values of the graph, and also making reference to the gradient of the graph. To achieve this specification point, it is also useful to know 2 equations. One, the gradient is the change in y over the change in x, and also that the average speed equals the total distance divided by the total time.